Hi, Art Kurtz here for Easy Access Math. And today we're going to look at more systems of equations or equation systems. And these three I have here, they're a little difficult. So if you'd like, why don't you watch our first lessons, starting with lesson 1 on equation systems. It'll show you the basic concepts. These are a little trickier, but they can happen to you on a test, so you want to be aware. You know, sometimes you're really lucky. In the easiest format, one of the values will cancel right out. Also, on some tests, you're going to be asked for only one value, not both. So it's not going to have both answers on a multiple choice test. You can't use substitution then, because you're only looking for one of the values. It's only asking you for one, and so the answers will only be one of the values, the one that you're looking at. So now let's actually solve these three. Now look at this small one at the end. This was just a sample. I'm not going to work it out, but in the basic sense, if you're really lucky, one value just cancels right out. You don't even have to set anything up. I had a +3 and a -3. Like terms canceled out. I'm left with the other variable. But as the case may be, you may have to adjust one or even both lines. Now, in our earlier lessons, you had to adjust one line, and usually it was by multiplying by a number. It's possible you might have to multiply by a negative number if you have the same sign for the value that you're not looking for, and that's the one you have to cancel out. So here I'm looking for x. I need to cancel out y. And they have the same signs. I'm going to multiply the bottom line, because it's smaller, by 2, but by a -2, as you can see, because I want to switch that to a negative sign, and that would leave me with 4x, and this would change to plus, because when I do negative, all the signs will change. This will change to minus and multiply by 2. That was an imaginary 1 there. You know, when there's no number, it's a 1. And -1 times 2 is +2. Now that I did that -2, it can cancel out, and I'm left with 4 plus 4 is 8x equals 12. Divide both sides by the 2, by the 8. And I get x equals 12 divided by 8 would be 1.5 or 1.5 if you reduce that. Either way, that would work. And so, when you multiply by -2, I would get +4, a -2y, and the -1 at the end turns to +2 because it multiplied. And that's how you solve that one, by multiplying by the -2. It switches the signs. And I get a fraction answer. Unlikely to happen. It could. Of course, in math, anything is possible. But you would divide. Like I said, these are the harder systems of equation problems. Let's take a look at this one. I have the -2 and the -3. Let's look at this one first, because here I have a positive and negative, and I am going to solve 4x again. 4x. And I'm going to have to, in this case, because I'm looking to get rid of the y, multiply both lines. I have to adjust both lines. I need to get those y's to be a common amount. So I'll multiply this one by 3 and this one by 2. Kind of like getting common denominators, remember, with fractions? And that would give me, I'll rewrite it here, 3x plus 6y equals 7 times 3 is 21. And here I'll have 4x minus 6y equals 7 times 2 is 14, and that gives me 7x equals 35. And you see how the y's cancel. The 6y cancels with the 6y. I now divide both sides by 7, and I get x equals 5. Now, let's take a look at that last one. You see, it's just a matter of getting rid of the part that you are not looking for. Look carefully, because you may be asked to solve for x or y or any letters that they give you, and it could be the first or second. You may have to adjust the top or the bottom line, or in this case, both, to get the letter you're not looking for to be equal. And so in this case, I had to multiply the top by 3, the bottom by 2, and I get 6 that cancels. I add up everything else, and I add up the changed amount. So 3 times 1 is 3, 2 times 2 is 4. They add up to 7. 3 times the 7 that was there is 21. 2 times the 7 is 14. That adds up to 35. I solve for x, and I get x equals 5. My x value equals 5. So here, with these numbers, I ended up with a fraction when I changed those numbers over there. Now, I will look at the last one. This one's the most challenging because I have to not only multiply both lines by a number, I have to change the sign of one line and multiply one line by a negative. It's your pick. It'll come out the same way no matter which one you choose. So let's try to make the top one a negative. And we'll make that a negative 3. And I'll make the bottom one a negative 2. No, sorry, my mistake. Only one line gets the negative. If I did it to both, then I'll be back to square one. My problem would be they'll still be the same signs. Only one line gets the negative. So yes, positive 2 for the bottom line, or I could have done positive 3 and negative 2, but you're only making one line the opposite sign because that will change the sign of the number that you want to clear out and get rid of. Only one line gets the opposite sign. So I made the top a negative 3 and the bottom a positive 2. So not only did I have to adjust both lines, but one line gets adjusted with a negative number because both of these were the same. We need those canceling numbers to be different. So let me rewrite it. In green, I have negative 3 times 3 is negative 9x. Negative 3 times negative 2 is positive 6y equals negative 3 times 24 is negative 72. And over here I have 2 times 4 is 8. X. 2 times negative 3 is negative 6y equals 2 times positive 31, which gives me a positive 62. And just make sure I did that right. And now I'll get my numbers. Of course, the 6y's cancel. They're gone. I have a negative 9 and a positive 8, which gives me 1x, or negative x. Negative 1x. I, of course, don't have to put the 1 in. These canceled, and 72 and 62 gives me a negative 10 difference. Unlike signs, you subtract and give it the sign of the higher, which is negative. Rules of sign numbers coming into play here. Now, I don't want negative x. I almost have my answer, but I have to divide both sides by negative 1. That gives me x, positive x. I don't want the negative x. I want the positive x. X equals, and negative 10 divided by negative 1 is positive 10. So x equals 10. And that's how you do a pretty challenging system of equation where I had to not only adjust both the top and the bottom, but I also had to adjust one, and that was my pick, and I chose the top, but only one, not both, by a negative of the number, because both of the signs that needed to be canceled were the same. If they're both positive or both negative, you're going to have to multiply one line by a negative number You may have to multiply both lines by numbers, but only one line by a negative number. So here we had some challenging systems of equations. Now, you're likely not to get something this challenging on an exam, but you do yourself a favor though. I would recommend you review the more basic systems of equation problems on our YouTube videos. So keep watching.